Swayam Prabha. Digital India. Educated India.
In the previous lecture we started discussing about thin film dynamics, and we started looking into the governing equations and the boundary conditions, and we tried to identify that what are the boundary conditions for the free surface, and in terms of the tangential stress balance and the normal stress balance and the kinematic boundary condition. Then we tried to derive the dimensionless forms of the momentum equations, and let us go to the slide to summarize the various dimensionless forms. So, these forms could be derived by expressing u and v, u, v and p in terms of the small parameter epsilon, u equal to u0 plus epsilon u1 plus epsilon square u2 and so on. Similarly, v and p, and these are the equations. The x and y momentum we derived in the just towards the end of the previous lecture, and the continuity equation form is quite obvious, that is this one. Boundary conditions, the bottom wall boundary conditions, the bottom wall boundary condition is quite straightforward, the no slip and no penetration, and we will now devote significant attention towards describing the boundary conditions at the top wall. So, the kinematic boundary condition, how do we express it in terms of the small parameter? So, let us try to work it out in the board as much as possible, and then we will refer to the slides. So, you have this is the kinematic boundary condition. So, what is f dash y dash minus h dash what is grad f dash right. Where I and j are the unit vectors along x and y direction, and x prime y prime directions are the same. Now, let us simplify this. So, to simplify this, what is del f prime del x prime? That is del h prime del x prime, right, because in f prime h prime is a function of x prime. What is del f prime del y prime? 1. So, this you can write h prime scales with h0 and x prime scales with LC. So, when you write it in a dimensional form, a dimensionless form, it is h0 by LC into del H del x, H0 by LC is epsilon. So, minus I epsilon del H del x plus j. So, what is the normal vector? For getting the normal vector, you also require to calculate mod of grad f dash. Okay. So, what is that? It is square root of epsilon square del H del x whole square plus 1 to the power half, right. So, what is n cap in the leading order? If you divide this with this and consider that epsilon is a small number, then what will be that? It will be minus I epsilon del H del x plus j plus higher order term, right, because in the division this term will tend to 1 as epsilon tends to 0, okay, when you divide this with its mod. Okay. So, now you have del f dash del t dash. So, this equation